and maintain Azure resources. It's worth 10 to 15% of the overall score. That major objective is broken into two sub-objectives: monitor resources in Azure and implement backup and recovery. In this section of the course, we're going to be talking about monitoring of resources. This includes metrics, loggings, analyzing and querying logs, alert rules, network watcher, and configuring and interpreting monitoring of these various Azure services. So I flip over to the Azure portal, and if I'm on the homepage here, I can see that there is a tool called Monitor. You're going to find it. I have it favorited, and it's in my menu on the left here. Or you can go under All Services, and if you type Monitor, you can see Azure Monitor as a service. Okay. Now, Azure Monitor is a centralized dashboard that contains all of the diagnostics, logging, metrics for all of these associated services. It can even work with external servers if you're running in different locations on premises or in different clouds if you have the right agent running. And we'll deal with that. We're talking about virtual machines. I'm going to start off going down here under the Insights, and we can see a list of all the services that Azure Monitor can support. The first one is applications, web apps, app services. Now, the app services use a tool called App Insights or Application Insights in order to extract the metrics and the diagnostics from app services and put it into a workspace where Azure Monitor can access. Virtual machines can also be monitored from within Azure Monitor. Virtual machines, like Windows or Linux virtual machines, often require an agent to be installed, a piece of software installed on the virtual machine that will then extract the performance and health data and send it back to Azure Monitor via a log workspace. So when you have a virtual machine, you're going to basically install a piece of software. Now, what we can do is, like I said, if we had Azure VMs, we can basically turn them from being not monitored to monitored. I don't have any configured right now, but we'll deal with that. It also supports logging and diagnostics for storage accounts. And you can actually see transactions against your storage accounts, the end-to-end latency, the server latency relating to certain storage accounts, determining which storage accounts are running close to capacity, etc. So you get some information out of your storage account here. It works with Kubernetes containers. So you can install, again, like an agent to extract data from a Kubernetes cluster and get the CPU and memory. And that's the stuff that comes with AKS, but you get more comprehensive data by enabling monitoring services to extract the data. Now, there used to be separate tools for monitoring networks, and now that's integrated into Azure Monitor. So if you want to check about traffic over a virtual network or whether one potential network can talk to another, let's say you have two networks that are peered and you want to test that, you can see that there is actually a diagnostic toolkit, and you can troubleshoot and do various things starting from here. We can also see a map of our VNets within our account. Because I don't have any VMs, I don't have any VNets, and so topology isn't going to do as much. But if you want to see a visual diagram of your servers and networks and connections, you can see that under topology. It seems like the SQL database monitor tool has been in preview for many, many years. So authentication issue is interesting. So you can obviously use a monitor to access Azure SQL database data and get that into Azure Monitor. So it supports Cosmos DB, Key Vaults, Azure Cache for Redis, Stack HCI Service Bus is now in preview, and a few others. So that is just getting performance and health data out of these related services. Azure Monitor also deals with what are called diagnostic logs. So if you go under settings and diagnostic settings, we can see a bunch of the services in our account. And then we can say that most of them don't have diagnostics enabled. All right. If I have this particular storage account, blob containers got diagnostics enabled, but I don't have it on the storage account as a whole or any of the other like queues or tables or files or things like that. Now, you can go, if you are in a particular service, let's flip over to a storage service. So I go to say storage. If I go under the storage account, you'll see in any service really, going down under monitoring, we can see diagnostic settings has its own tab. Now, like I said, I do have diagnostics enabled for the blob here, but I don't have it enabled at the account level. And so I can click on that and say add diagnostic setting. And this is simply to get the transaction logs from the storage account. I can say send to log analytics, give this a name. And this is now going to start collecting log data from this storage account and send it into the log analytics where Azure Monitor can then report on it. So we're going to talk about in this section of the course, we're going to talk about logs, and we're going to talk about running queries and things like that. So we'll get into some of these other interesting elements of Azure Monitor in the next video and the videos that follow. I've created a couple of more resources to play with here. I've created a virtual machine and I created another web app. Now I'm in the Azure Monitor and under settings, diagnostic settings, and I filtered it to a specific resource group to make it clearer. And we can see the types of resources that we can enable diagnostics on. So we can enable diagnostics on a network interface card. We can enable it on the public IP address of a virtual machine, and as well as the network security group. Now, what we're missing from this list is the virtual machine itself and the web app itself. Okay, so these are just the ancillary objects that get created alongside of the primary resources. So let's look at an example. If I wanted to track the traffic coming in and out of a virtual machine, I can track that through the network interface. Network interface is not going to know anything about the CPU utilization or the memory utilization of the VM it's attached to, but it is going to know about traffic. So I can say add diagnostics, and I just want to grab all of the metrics for this, and I'm going to call this a diagnostic 2, and I'm going to send it to a log analytics workspace. Now notice I can also additionally send it to a storage account, send it through the event hub to be processed by some listener or some other third-party solution. So I have up to 4 destinations for the metrics coming from this network interface card. So I'm going to choose that and click Save. But I'm also interested in the performance of the actual virtual machine. So I'm going to go back to the resource group. I'm going to find the virtual machine, which is here. So we go under monitoring. Now we can have application insights on a VM just like we have on Azure App Services. So that is an option that will track application level events. So if you have software running in your VM, then you're going to be able to get that data out of the VM using App Insights. We also have diagnostic settings. Now Azure Monitor already collects basic metrics like CPU, disk, and network without any additional software. This is just a native function of Azure VMs. But if you want more insights into the VM, you need to enable what is called guest level metrics. Okay, and using an agent. So this is a piece of software installed on the VM that collects this. So it has to have a storage account to access this. And so I did create a storage account specifically for this purpose. And I'm going to say enable guest level monitoring. Now that's obviously going to take a little while because it's going to have to install the software, and then it's going to have to restart the VM. It's a disruptive event. So we're just going to let that install and restart. All right, so we do have the Azure Diagnostics installed on this VM at this point. Now, we still have this option of installing insights to get that out of the virtual machine as well, which can be enabled here. Now, let's flip over to the app service that I created. So go into the resource group. And I created an app service. And if we go down under monitoring and diagnostics settings, we can see that we can collect certain types of diagnostics from the app service. This is HTTP logs, app service console logs, application logs. So if your app puts out stuff to the console or pops out stuff to the app log within Windows Event Viewer, you can get that access. So who's logging in securely or failing and things like that. So let's add diagnostics for our app service. Now, in these types of situations, we can pick which ones we want and which ones we don't want. So let's say we don't care about the access or audit stuff, but we do care about the HTTP logs and the console logs, etc. Again, we can send that to Log Analytics Workspace and say save. And so we can see there's a few different ways that we can enable diagnostics, one from within Monitor and also for additional services within the services themselves under diagnostic settings. For applications, you often have the choice between application insights as well as lower level HTTP logs and CPU and metrics and things like that. So we saw in the last video that for virtual machines, we can turn on diagnostics in order to get the various operating system level metrics outside of the virtual machine. The other thing we might be interested in is the logs. And the logs are accumulated through what is called insights. Actually, Microsoft is migrating from a log analytic agent into a VM Insights agent. So if I go into VM Insights and I say configure insights, I'm going to see that I have a virtual machine and insights is not enabled. Now I can click this button to enable insights. We can also, if you remember from the last video, go into the VM under monitoring. We could go down to logs even or to insights and say enable. So this is directly feeding data from the virtual machine to an Azure Monitor agent. Now the agent needs to be installed on the VM. So this is a little disruptive in terms of installing a piece of software on the VM in order to collect insights. Now you'll see that it says for Azure virtual machines, the CPU, disk, and up and down state does come out of the box. You don't need this for that very, very basic data. But if you want additional monitoring capabilities, that's when you need to install this agent. So I think that the agent is actually installed. My notification told me the deployment succeeded. So let's flip back to Azure Monitor under VM Insights to say configure insights. And now we'll see that the VM has gone from being not monitored to being monitored. I will point out that these agents sometimes need updates. And so you might see a button on this screen if the agent is particularly out of date and it wants you to manually trigger agent to be updated. So that could appear here. So now, besides collecting the metrics data, we are also collecting log data from that server. Log data often would appear in Windows, at least, in a Windows event interface. Like if you're familiar with the Windows event viewer at all, then you can see that there are Windows logs, application logs, and security logs and system logs and things like that. And so you're basically using an agent to extract these logs from the VM itself into the monitor that we can then run queries on. So that's going to take time to produce data. We're going to talk about custo queries in a moment, but that's all you need to do in order to extract some of these application and system event logs out of Windows, at least, and into Azure Monitor for centralized monitoring. All right, so we do have a couple of things that are collecting diagnostics, a virtual machine, an app service, the network interface card. So first thing we're going to look at is this concept of metrics. So metrics really is the easiest thing to explain because it's the CPU, the data in, data out, number of requests, things like that. When I go to metrics, I do have to choose a resource. So it starts with choosing the subscription, and then going down, we can choose the resource type. So I want to choose the app service, let's say, and then to choose the actual resource. So I'll choose this web app. And you can see I've got one selected scope, and I can say apply. And now we can see what we're talking about when it comes to metrics. So metrics really is centered around a graph. And we can choose, when we do the metric dropdown, we can see that there's a couple of dozen options. Everything from memory working set, number of connections, CPU time, data in, data out, even the garbage collections, various error states from 400 errors, 200 success, which is not 200 success, but 201, 202, where there's no body response, etc. IO bytes per second, things like that. So I'm going to go and choose the CPU time. And I can see whether I want to count the number of CPU, which doesn't really make sense, but the sum, the minimum, the maximum. Right now, we're on a very long time scale. It's a 24-hour graph. And so we got nothing because the app didn't exist. And then we have a sudden spike of CPU time. And so let's focus on the past 30 minutes of CPU time. I can also choose the granularity. So I can say I want to see the last 30 minutes and I want to see it down to the minute. So now I can see, a few minutes of CPU graphs, and we can see how many milliseconds of CPU is used. Now that might not be entirely useful. I believe there is let's look at the number of requests. So this is the web app that I was playing with, and you can see I did sort of a spike of 8 requests in a single minute, and then a few more the minute after, and now nothing. So this is how we're getting access to looking at the basic metrics of an app. Now, it doesn't have to be an app service. I can change the scope here. Right, I can go to, let's say, for example, now you can't choose resources that are of a different type. You can't put a web app and a VM on the same graph. So I'm going to remove this one scope, and I'm going to add in the virtual machine as its own second thing. Say apply. Select a metric. I can see that I want a percentage of CPU utilization. And we're still in the 30-minute, and we saw that there was a spike when the VM was created, up to 50% CPU, and now the CPU is 2%, 1%, because nothing's really happening with that virtual machine. So this is a centralized location where we can get various data about our resources. Now, beyond metrics, you might want to be interested in the various logs that a resource puts off. So log analytics goes, and we can run queries under the logs section. So once again, we have to select the scope. I'm going to pick that scope, and we can pick the entire subscription. But what I'm going to do is I'm going to just drill down a little bit. I'm going to go into the resource group. Now, when selecting a scope, I can select pretty much any resource or resource level inside. So I can select the subscription, I can select the resource group, the storage account, the type of data being stored in the storage account, things like that. We can see the VMs in here. We can see the app services. So this is going to allow me to run queries against this data. Now, for the sake of this demo, I'm going to choose the entire subscription. So I have a pay-as-you-go subscription, had it forever, and I'm going to choose that entire subscription and say apply. Now, it's going to be easier if I minimize this menu and make sure this menu is open. Now, every type of resource within Azure that collects diagnostics and logs has different table names. So on the left here, we see this tab called Table, and I can look under App Services, and I can see the incoming HTTP requests of an app service, as well as Azure Activity and Azure Metrics. Azure Activity and Azure Metrics are sort of common tables. You'll see this under a lot of services. So let's say if we go under Load Balancers has Azure Activity, Virtual Machines has Activity and Metrics, but it also has one called Heartbeat. And once per minute, a log is created in this log analytics, once per minute, and that's called the Heartbeat, and that goes in the Heartbeat table. Now, I don't think one of the things that the log query suffers more than the metrics is the lag between the time that the logs are collected and the job runs to process the logs for this. So even though I've had a VM that's probably been running for half an hour at this point. I'm going to run this, and you're going to see that it's giving me this error even. It can't even find such a table called heartbeat. So even though the VM does exist and we have diagnostics turned on, it's way too early for the data to have been processed. I'm going to go under Azure Activity. Now, Azure Activity is, like I said, it's a common table to many different of these service types. And if I just want to, let's look at the last 4 hours. So there's this time range, and I can filter myself down and say run. Then I'm going to see things that I've done against my account in the last 4 hours. And I can even see that the current time is close to 10:30, but the last activity that was recorded was 8:40. So it's about 2 hours, just under 2 hours behind processing this. So like I said, it's not a real-time log processor, but it'll catch up. So you'll see I just entered the table name Azure Activity, it double-clicked it, it went into this window, hit run, and I'm getting results. This is very much like SQL Server Management Studio, where you have a query window and you can write, with SQL Server, you write SQL queries and you can execute them and see the results. Well, this is not SQL. This is called Kusto, K-U-S-T-O, or Kusto Query Language, KQL. So Kusto is its own query language, but very similar to SQL. And you have tables, and you can basically write queries and get results. So let's say I wanted to filter these results. I've got 12 results from this Azure Activity query in the last 4 hours. Let's say I wanted to filter it down. I could put a where clause. I could put a group by. I could do various things. One of the things that's worth looking at is this queries tab. And so queries is some pre-built queries that Microsoft is offering that might be interesting. So for instance, let's look at under virtual machines. If I wanted to see computer with missing updates, I'm going to clear out this window and click on computer with missing updates. Now I can see that it's pulling from a table called update. Then there's this pipe symbol and the where clause. And then there's basically, this is again, KQL language in order to do sorting and things like that. Say I don't want that one, I can erase it, malware detection. And again, it's going to check this protection status table and do a where clause and even a summarize in order to see if there's any threats detected. So they have these pre-built queries. You can build your own, you can modify them, you can save them, okay? You can write alerts based on the results of this, stuff like that. So this Azure Monitor allows you to look at the log tables, the diagnostic logs from all your services where it's enabled. And you can look at the raw data in terms of looking at the contents of the table. And you can write queries or even use some of the pre-built queries to get the contents of this. So here's one that says show logs from Azure Activity. And you can see it's only going to pull the last 10 records on order of time generated. So I know that's going to work. So this is how you can use Azure Monitor to help you in terms of finding problems, diagnosing problems, and things like that. So this video is going to be a little bit of a different video in that what I'm going to do is I'm going to the official Microsoft Learning GitHub for this exam, AZ-104, and we're going to go through one of the labs together. And so right now, this, obviously Microsoft has official training for AZ-104. It's often very expensive from official training partners, but they do make their labs available, and this is a public repository. So what I'm going to do is I'm going to go to the GitHub, this link to labs, and we're going to look at the traffic management lab, because this is the one that deals with load balancers and application gateway, and that could be very interesting to see in action. So this is the HTML-friendly version of traffic management lab. Now, I'm going to warn you in advance that this is going to take a little bit, so almost an hour to get through the work of provisioning some VMs and putting some load balancers in front of it and application gateway. So if you don't have that kind of time, or you want to continue on with the lessons and not really go through a lab simulation, then feel free to mark this video as complete and skip to the next one. But if you do want to see Azure in action, maybe you don't have access to it yourself, or you just want to see these things get created, let's get through that together. So the scenario is that there's a public website and you want to load balance incoming public requests. You need to have images and videos from different virtual machines. We saw this creating an application gateway that you can filter based on path. You've got a level 4 load balancer and a level 7 load balancer that you can choose from. All right, so I have gone ahead and downloaded the files. The GitHub repository contains both the template and the JSON files. So I've downloaded that to my machine, and we are going to go into the portal now, and we're going to go through this together. So the first thing it has us do is to find deploy custom template, which is one of the first things we need to do. So we're going to deploy the virtual machines. We're going to say build your own template. And we're going to say load file. And I've chosen the VM's template.json from my local machine. We do have to save. And then we're going to go to the parameters. There's a parameter file. We're going to load file for that. And I'm going to say save. Now we are going to be responsible for a few things, making sure the subscription is correct, choosing a resource group. So I'm going to create a new resource group for this. And as of 2013, Microsoft no longer provides passwords in any of their template examples. So we do have to give the admin user here a password. All right. Now this is going to try to create VMs of a certain size. And so we do need to have, let's look at what's being created here. If I hit the create button, it's going to try to deploy VMs, and it's going to see if my subscription has those available. There are obviously limits to the number of VMs on free plans, and also on some of the pay-as-you-go, you can run into those limits. So let's keep an eye out for that. Now we do have to wait for all of this to be created. It's going to take about 5 minutes. So let's let this run. Now we can't see what's going on here. There's a network security group, 1 virtual network, 3 network interface cards, 3 virtual machines, and now it's running some deployment code in a virtual machine extension, probably a PowerShell script. You can actually go look at the ARM template as a fun exercise, and we can see that it is running this PowerShell script in order to get IIS set up. So that's successfully deployed, we think. Let's go to the resource group. All right, easy step 1. Now, the next step has us creating a Azure load balancer. We're going to take 2 of these VMs, 0 and 1, and put them behind a standard load balancer. So let's look for load balancers. We're going to say create. Put this into our resource group. We're going to deploy this in the same region as the virtual machines. We're going to choose the standard load balancer. Keep in mind the basic is retiring, not too long from now. It's a public load balancer, and we're going to leave this deployed in the region. There is the option for global load balancer, even though we don't need that in this particular case. All right, so now we need a public IP address for this. So we're going to create one. It's called this name. We need an IP address, and we need to create a new public IP address. Give it a name. Well, I'll leave it as not zonal, so basically regional, static, standard, safe. And now I'm going to say save again. So now we're going to have a front end. This is where we put the virtual machines in the backend pool. So we're going to create a backend pool, give it a name, put it into the existing VNet, choose by network interface card, and we're going to add VM0 and VM1, not VM2. Say add. We can say save. Next up, we are going to talk about the inbound rules. Now, according to the lab instructions, we are not going to add the inbound rules right now. We're just going to say review and create, and then click create. So let's do that. So we do have to wait for this to deploy, and we'll wait for that to happen. So that deployed, and now we can say go to resource. And under settings, we're going to add our load balancing rules. So we have our front end, we have our back end, now we need a way of connecting the two. So I'm going to say add, give it a name. We're going to choose the front end, we're going to choose the back end. For TCP, port 80. And we're going to make sure that it's a straight through from port 80 inbound to port 80 in the back end. We do need to create a health probe, it's mandatory. So we're going to say create new. And that is a TCP health probe. All it's doing is it's checking that this port can be opened. It's not making a connection. It's not pulling data from the server. It's opening the port. If the port can be opened every 5 seconds, then that's considered a healthy server. We're not going to enable session persistence. We'll leave all of these with their defaults. Now, one thing it wants us to do, according to the instructions, is to grab the public IP address from the front-end configuration page and open a browser window and navigate to that address. So it says now, hello world from VM1. It's going to say VM0 or VM1 because those are the only two servers. It might take a few refreshes in order to get it to say 0, but eventually it will say 0. All right, so the next set of instructions talking about the application gateway. We're actually pretty well going through this. So what we are going to do now is we're going to provide layer 7 load balancing, which is basically at the application level. It can analyze the path of an HTTP request and make decisions based on which domain name you're going to or what path along a server. So the level 4 load balancer cannot do that. So let's go ahead and create an application gateway. Now, in this case, what we're going to do is have our application gateway direct traffic to VM1 or VM2 in this backend pool. So I'm going to follow the instructions. So it says to me to go to virtual networks. So virtual networks. Go into VNet 1. And we do need, the application gateway needs its own subnet. It cannot have any other devices running on the subnet. So we're going to have to create an application gateway subnet. And I'm going to follow the settings that it's asking me to place. So I'm going to say here for /27. So that's what it's asking for, and that's what I will provide here. And then I can just say add. Now we do need to go into application gateways, and we're going to create an application gateway. We're going to put this into our lab. Give it a name. It's going to be the same region all along. Standard v2. We're not going to do scaling. Minimum instances of 2. And we're just going to deploy this to zone 1, according to the requirements of the lab. Right? So we already have the virtual network, and we already have the subnet ready to go. Next, we go to the front end. We need a public IP address for our application gateway, so we'll choose that. We'll say OK. Next, we need our backend. So we're going to give it a name. And what we're going to do is we're going to choose virtual machines as our backend, and we're going to choose NIC1 and NIC2, again, according to the instructions. Okay, so those are the two ones, not 0. So now we can say add. And now we want a second backend pool. This is going to be the one that will have images. And again, following instructions, it's telling us to choose NIC1. And a third backend pool. This one's going to be the one for videos. Now we need to set up the rules in order for traffic to come through the front end to go to one of these 3 pools. So we're going to start with priority 10. Listener has to have a name. Protocol 80 we've been dealing with. Basic listener. Switch over to the backend targets. And we're going to choose the application gateway backend pool. And we are going to have to create a new set of settings because this is mandatory and it doesn't exist. So we'll just leave the default settings, no cookie affinity, no connection draining. Now we do need to have multiple targets for this path-based rules, right? So we're going to say add multiple targets. For the images, we call this images. We're going to choose the settings that we just created, and we're going to send it to the images target. And we're going to do it again for the videos. So for the video path, we're going to call this videos. It's going to be the same rule and we're going to do the video target. So we're going to add that as our routing rule. We don't need to have tags, and we can say review and create. Now, application gateway takes a few minutes. Load balancer is quite quick. Application gateway actually does take 5 to 10 minutes. So we're just going to say create, and then we'll let that run. We're almost done. So maybe Microsoft's gotten better at this, but that was about 4.5 minutes. That's not too bad. All right, so we're going to go to the application gateway that we just created. And we're going to go under monitoring. And we're going to look at backend health. And we have our various resources. Remember, we have 3 backend pools, but those are only pointing to 2 resources. So 1 and 2, 2 and 1, they're all healthy. If we go to the front end public IP address, so we can copy that. So this is going to the front end of the application gateway. So remember, it should be between servers 1 and 2, and there we see 1 and 2. But it also handles image. That comes from 1, and it also handles video, and that should come from 2. So in this lecture, reviewing the lab from the official Microsoft AZ-104 course, Implement Traffic Management, which you could find, we were able to create a load balancer, standard load balancer that points to 2 machines, 0 and 1, to presumably display a website. And we also implemented the application gateway pointing to machines 1 and 2 to also display a website and also distinguish between servers based on the path being presented, which could help with traffic management. Last thing we're going to do before going is we're going to delete all of the resources. So I'm going to go to the resource group, and I'm going to say delete resource group. Thanks for watching. Let's continue on. So in